GEOS is an infrastructure that's composed by several tools and web interfaces that allow you to discover and access geospatial data produced mainly by satellite producers and also by in situ data. GeoViQua is helping GEOS because we are working on including quality indicators on search, but also on increasing the visualization of the quality indicators in order that easily a user can compare different regions of the map and discover places where the quality of the data is a bit below a certain threshold.
We've extended the traditional producer model to add some elements which allow a richer record of the data. And then on top of that, we've got a parallel model for user feedback so that users can actually record how they use the data, documents they publish referencing it, all sorts of reviews of the data, how they find it useful in their particular domain. And we can pull together the producer and user metadata to make a really rich record, which makes users who want to use that data much more able to evaluate it and to rank the different data sets to see how they will work for their purposes.
The geo-label will be a quality indicator provided for every data set in GEOS, and we are taking user-centered design approach to actually develop, implement and evaluate the geo-label. So far we've done 3 user studies to collect some data to identify what users actually want. We've done studies to find out what they want from actual geo-label, and we've done another study to evaluate some geo-label prototypes. Currently, we're developing the actual server to provide geo-labels on demand. We're hoping the geo-label will be a quality indicator that will provide some information for users to decide on whether data sets are relevant to them or not, and we're hoping that the label will be useful in data selection.
What we want to give the users of the end users of the system is a way of using quality statements for querying the data. So this reflects on the existing dataset and access broker, the DAB, which at the moment does not allow the users to include quality constraints in the query that they express. So that's why we have extended that in GeoViQua to allow the use of some, I think, 20 or possibly more quality indicators that the user can use to enhance its queries, to express the query constraints and then obtain results that are more fitting to his or her purpose.
We from S&T, we are developing the feedback server and client. The feedback server is based on the quality model that has been designed within the GeoViQua project, and it's meant to be able to store all the user feedback from both normal users, such as you and me, as very experienced users that use the detailed data sets, and then they can provide their findings and results and what they think of the data sets and whether it's complete, and they can put that into the server via a client interface that's just a normal page form that you can fill in and then submit it. And then it's stored into connected to the GEOS system.
The GeoPortal, what is currently available at the www.geoportal.org, is the web access point to the GEOS system. This GeoPortal is currently led by ESA. It is run by an European Space Agency contract, and we at the European Space Agency, we are in charge of the development of this web portal and its maintenance.
The main objective is to create a tool which combines data which in the future will be able to offer to the policy maker decision tools. And the second objective is to offer to the GeoViQua project data to build visualization quality data tools.
The scenario consists in using EO, Earth observation data from GEOS to monitor the flooding practices of the rice field in the Delta del Ebro. This area is a very important area because it's an area of wetlands, and wetlands are used by birds when they migrate. And during winter, usually the fields are dry. And with these practices, the European Commission has provided subsidies for the farmers to flood the fields and allow the birds to stay there. With remote sensing data, we monitor these practices and we ensure that the farmers do what must do.
Our motivation is the Ebro Delta, which is a very unique ecosystem, and there is a subsidy in effect to make sure that farmer practices do not disturb the habits of various species. And as many subsidies, it needs to be checked, which we are supporting with a novel visualization. And the benefit of that is that you can now, that the experts which check the subsidy can now see the algorithmic output together with the certainty of that output, which helps making decisions about the improvement of the algorithm, which helps making decisions about the payment of the actual subsidy, which of course is important to the farmers which operate there and which is always a cause of litigation.
It's now possible to get all kinds of data over the web. We can get data about maps, about air temperature, about ocean water quality, about all kinds of things. But what we can't see very easily at the moment is how good that information is. One way we can communicate that is through uncertainties. And these are derived normally by whoever produced the data in the first place. They give you an estimate of, for example, a weather forecast, and you can get an uncertainty associated with that. You can very rarely see that on the web these days, and what we want to do is make that information more available so that when somebody looks at some information that they get, for example, from the Global Earth Observation Systems of Systems, they can see the data together with some estimates of how good the data are, how uncertain the data are in particular regions of the globe.
Greenland is a web client for visualizing geospatial data, and it's based on the Common Web Map Service standard. What sets Greenland apart from other applications is that it's tailored to quality visualization. So if I connect to a web service that has quality metadata annotated to it, Greenland can automatically suggest a suitable visualization. And on top of that, Greenland is also very interactive. So I, as an expert user, can play around with the settings, look at different visualizations, look at them, compare them side by side, and also tweak the visualizations to my needs to really delve down into the information that is behind the data.
The GeoViQua is a tool that allows the users to see which metadata is documenting regarding quality. This is, for example, that people can see if some quality parameters is documented regarding the positional accuracy or thematical accuracy or other aspects, and not only to see if this information is present or not, but also which are the actual values of this metadata, so he can accept or discard this data set for their purposes.
GeoViQua is an essential project because the tools and the models that we are going to release at the end of the project will be used by several other projects funded by the European Commission in many societal benefit areas.